Hello, we're going to practice some implicit differentiation by the practice test. So the first problem is x squared y plus 3xy equals 2x. And if we're going to differentiate implicitly, we first scan a little bit and notice that we have the need to use product rule twice. Because here's a term that contains both x and y, and likewise here's y. So I have to be mindful of product rule and implicit differentiation. So derivative of the first, this term, times the second untouched, plus first untouched derivative of the second. And again, y could be solved for a function of x, but tough doing, so instead we're going to implicitly derive, which means we're going to write dy dx, like derivative of that quantity with respect to x. Just don't know what that quantity is. We're going to solve it by going through the back door, so to speak. Okay, product rule all over again. I'm going to count the 3 with the x as the first term, so derivative of the first term is 3. Second, this one untouched, plus first one untouched, derivative of the second, again, a dy dx. And on the right side, differentiating 2x with respect to x is 2. And then we're going to get all the terms that have dy dx in them on one side. So that would be these two. And scoot the others to the other side by subtracting them out, minus 2xy minus 3y. And then we're going to factor out the dy dx, which we want, and the other multipliers are out front. We're going to factor them here, and this is going to equal 2 minus 2x minus 3y. Solving for dy dx equals that quantity 2 minus 2xy minus 3y all over the factored part we don't want. And stop there. The next problem on the practice test involves writing both tangent lines to a circle. The equation for the circle is x squared plus y squared equals 21. And again, we need to implicitly derive. So 2x plus 2y dy dx equals 0. Derivative of constant in any kind of differentiation is 0. Solve for dy dx by subtracting 2x from both sides and then dividing by the unwanted multiplier. Will leave us with this, which is going to be our m. And notice that it's got both an x and a y in it. And if we picture the circle as one center of the origin with the radius, the square root of 21, which is about 4.58. We want to find the tangent lines at x equals 3.4. So we go out to 3.4 and up to where y is positive and down to where y is negative. We see we're going to have 2 points. So we're going to have 3.4 something and 3.4 minus something. It's going to be a negative y value. So before we can finish this, we need to find those y coordinates. And how you do that is to always go to the original. So we're going to solve for y, which will mean 21 minus x squared. And that's equal to y squared. We need to root it, and we need to account for both roots, the positive one and the negative one. So it's plus or minus the root of 21 minus, and particularly our x is 3.4, denominator, that comes out to plus or minus 3.07. So these points are 3.07 for this y and negative 3.07 for that y. Now we have to write the equations of the tangent lines, and I'm going to grab the other board. So we have our dy dx equals minus x over y. And we know that this is going to be our m. But we're going to have two lines, line 1 and line 2, because we have a circle that has two tangent lines, one at positive y, one at negative y. So we need to find the m for the first line. So find m1. So that's going to be minus x, so minus 3.4 over our y, which was 3.07 for this one, 3.4 positive 3.07. And that turns out to be approximately 1.11 but negative. And for line 2, we need to find its slope. So it's the same formula builder. So minus, and x is still 3.4, but now y this time is negative 3.7. Excuse me, 3.07. So we're going to put a negative down there, and that'll give us a positive slope. And that makes sense if you look at the drawing. This one is negative slope, and this one is positive slope. And you see that's what's coming up here. Same numerical value, 1.11. So our m1 was negative, our m2 is positive. So we're going to use point slope formula. And take the first line. We know y there is 3.07. Our slope is negative 1.1. X stays in the equation, and 3.4 is our x1. That tidies up to y equals minus 1.11x plus 6.84. And this is just algebra and arithmetic from here to here. You can look at the hard copy of the practice exam solutions. I took many lines to get there. So this is L1. And now we're going to finish L2. I hope there's enough space in the camera to pick this up. So this time around it's y minus a minus 3.07. And our m2 is positive 1.1. Our x is still the same old x, but this time it cleans up to y equals 1.11x. And oddly enough, it becomes minus. This one's going to be minus, and these, though positive on this side, need to be subtracted out. So minus 3.4 minus 3.07 is going to give us minus 6.84. So that's line 2. And so we have equations for both tangent lines to the circle. And doing these problem in the practice test is, of course, multi-layered, and you can get points for various stages. Just draw a sketch to get started, and then keep yourself